Hello everyone. In this particular lecture, I am going to explain about clipping circuits. So basically, till now we have seen the linear wave shaping. In that, the shape of the input signal can be altered using the linear network. And in our syllabus, we have low pass filter and high pass filter in that particular criteria. Now, the shape of the input signal can be altered by using the nonlinear circuit. And this particular process is said to be nonlinear wave shaping. So, what is nonlinear circuit? Nonlinear circuit includes at least one nonlinear element. Okay, even though in this particular circuit so many linear elements are there, if you have at least one nonlinear element, then we can able to tell that particular circuit is nonlinear circuit. The operation of the circuit is mainly dependent on this nonlinear element. Okay, even though so many linear elements are there, the basic operation of the circuit should depend on this particular nonlinear element. Then we can tell that particular circuit is the nonlinear circuit. And what is nonlinear element? The VA characteristics should not be a straight line passing through the origin. For example, diode, if you take, V is the voltage across the diode, I is the current flowing through the diode. Then if you draw the VA characteristics, we know these are exponentially related characteristics, because I is equal to I naught into e power V by eta Vt minus 1. So voltage and current are related exponentially. So I is proportional to e power V. Remaining I naught, eta, Vt and 1 e all are constants. So I and V are related exponentially. So diode is a nonlinear element. So the circuit which is involving the diode and the operation of the circuit is mainly based upon this particular diode operation, then we can able to consider that particular circuit is a nonlinear circuit. Okay, and in this particular by using this nonlinear circuit, if you have the wave shaping process, then that particular thing is called nonlinear wave shaping. And in our syllabus we have nonlinear wave shaping can be done by using two types of the circuits. One is clippers and second one is clampers. So little bit information I will give regarding the clamper also, basic definition. So clipper is nothing but certain portion of the input signal can be removed. Okay, clipping is nothing but removing. So certain portion of the input signal will be removed. That may be entire positive portion, that may be entire negative portion, that may be some portion of the signal which is above certain amount of voltage, or some portion of the signal which is below the certain amount of voltage. Okay, like that we can able to remove the portion of the signal, or above and below some reference voltage levels. Okay, that is called clipper or clipping circuit. And what about clamper is nothing but DC restorer or DC inserter. Okay, that means a DC can be added to the input signal. That means the signal can be shifted upside and downside. If you add positive DC, okay, then the signal will be shifted upside. If you add the negative DC, the signal will be shifted downside. For example, I have taken a pure AC signal like this. That means positive portion, negative portion both are equal. Now, if you add for this particular signal, if you add plus 2 volts, then what will happen? The signal will be shifted upside like this. For example, it is 2, it is 0, it is minus 2. By adding 2, it will be 4, 2 and 0. Like this we will get. Every value of this particular signal will be taken by this particular 2. That means maximum is 2, 2 plus 2 is 4, minimum is minus 2, minus 2 plus 2 is 0. Like this we will get the entire waveform. Okay, then if you add minus 2, okay, if you add minus 2, that means the signal is like this, only same signal I am taking, whose value is changing from minus 2 to 2. And if you add minus 2, that means if you are subtracting 2 from this particular signal, every value should be subtracted, okay, with 2. Then what will be happening here? 2 minus 2 means 0, that means peak value 2 will be shifted to 0, and minus 2 means minus 4. So like this you will get, so signal is entirely shifted downside. For example, if you add minus 5, what will happen? If you add minus 5 to this particular signal, peak value is 2, 2 minus 5 means minus 3, and negative peak is minus 2, minus 2 minus 5 means minus 7. So the signal is changing in between -7 and -3. Like this you will get. That means if you are the negative DC, signal is coming downside. If you are the positive DC, signal will be shifted upside. Okay, this is about clamper operation. But in this particular lecture, we are going to concentrate on the clipper only. So what is clipper means? Just now I have told it is an electronic circuit by which we can able to remove certain portion of the signal. What is the meaning of that one? So here I have taken one full cycle like this I have taken. You don't need to take always this sinusoidal signal only. You can change the signal also. For example, your reference voltage is 0. Okay, 0 volts I have taken. This signal is changing with respect to time. So you want to only the portion of the input signal which is above 2. Okay, you don't want the signal below 2. That means you should get like this. Above 2 the signal is available, below 2 the output is 0. Above 2 the signal is available, below 2 the signal is not available. Like this you can able to get. Or you can have the signal which is just above 2 volts. So while drawing this particular clipper outputs, you can able to take the reference voltage level and you can able to take the input reference like this. In order to draw the output signal properly, always you can able to take like this, and you need to mark the reference voltage too. And using the clipper you can able to have the input portion which is just above the signal. That means below the 2 volts can be removed, or you can able to have below 2 volts and you can able to remove above 2 volts. Anything is possible. So here I will draw above 2. Above 2 is available, below 2 is clipped. That means like this you will get. Okay, the output signal is nothing but this thick line. So you will be having the output as this particular thick line only. That means above 2 whatever the input portion is there, same portion will be coming as the output, but below 2 has been clipped, has been removed. Like this you can able to take the definitions of the clipper circuit, and in this particular slide only I have explained about the clamper also.